Hello everybody, welcome to this talk. We'll be talking about how to build a ML-powered Android live streaming app. Now, who here actually develops on Android? Show of hands. Okay, so this is a good proportion, but it's obviously not the majority of people in the room. So we're going to talk about the Android stuff, but I'm not necessarily going to try to hammer everybody over their heads with that stuff. So anyway, why am I here? Who am I? Well, first off, before I present myself, I'm going to say a big thank you to Google. I'm part of, like a lot of people that are presenting today, the wonderful little network of Google Developer Experts. So it's Google's way of recognizing folks that have been presenting a lot and doing a lot of like activities in the community. And so they're nice enough to sponsor a lot of our travel and all of that. Of course, I'm from Montreal, so today it's not like I'm getting an actual monetary help, but they are tremendously helpful to the community, so a big thank you to them and for the event. So, about myself, my name is Etienne Caron. So I here am now talking on behalf of a small consulting company I started a couple of years ago. So what have we done at this small consulting company? I usually talk about these things because they are related to today's topic. So one of the recent projects I've done, you might have seen, like I've been presenting this over and over again, so I'm kind of worried about boring people about this thing. But this is a nice story we developed for Bell Canada for their Formula One marketing event a couple years ago. So what was it? It was a remote-controlled RC car that we were controlling over WebRTC. And this project was quite interesting for a lot of reasons, but effectively we were letting people on the island at the Formula race play around with little cars on a racetrack, and it was quite a lot of fun. So I learned a lot of interesting things from that project, and I'm going to share a few things today. Where they become relevant with today's main subject was effectively live streaming and machine learning, is that we did do quite a few interesting things on the machine learning front with this project. So first off, when we were building our prototypes, we didn't have access to the actual racetrack, and we wanted a way of tracking the cars around the racetrack and effectively saying who's in first position, second position, and all of that. And the idea we had for this project is to put 4 different cameras around the racetrack and try to locate the cars and track them from one frame to the other. But obviously, since we didn't have the actual physical track at first, and you need to train these algorithms, you want to be ready ideally more than a week before the event. We used digital twin techniques with YOLO V8 model, which was cutting edge at the time, pretty much. And so this is like the demo of little race cars running in Unity. And we just took the 3D plans we had of the track, ran that little fake demo of people driving very badly, and trained the algorithm to recognize the cars over that digital twin. So that was kind of an interesting twist on things. The other thing you can see at the bottom is basically what results that gave us. So we were able to not only track where the cars were and which position they were in, but we also kind of be able to track if they were out of bounds. So if we wanted to effectively slow somebody down that was cutting in the grass, we could software-wise tell the car, hey, slow down, they're out of bounds right now. Another contract we did for my company is we worked on this caper cart for the Instacart company. So I've presented again about this a year back, I think even here, if I'm not mistaken. And the relevance to today's topic, and why I'm talking about this, is that we learned a lot about computer vision when we were doing the contract for Instacart. The mandate we had with them was to improve the time that it took to actually scan produce when you were checking out inside the cart. So as you might have, I gloss over details because it's not the main subject of the conversation here, but we effectively had with this project checkout counters in the shopping carts that weigh the produce and everything. And the thing is that when you do that, when you want to scan produce, if you've been at the grocery aisle with the automated checkouts, it's a lot of clicks, right? You need to click around, say, I'm selecting produce, I have to enter the code, no, it's that type of banana, etc. So we were trying to come up with machine learning algorithms, vision algorithms that would help sort of skip a few steps. And so that was our mandate. And the brunt and the biggest part of the work was effectively making this stuff work in very limited devices, effectively Android tablets made by a company called Rockchip, if you're familiar with them. In the Android world, whenever you get like the cheapest Android phone on Amazon, it's effectively probably a Rockchip. So our mandate was to really optimize the code and make sure that we could do some machine learning on device and still have it be a bit useful. Anyway, at this point, and coming back more to the main story today, we started thinking at the company, me and my partners, we were like, well, consulting services, it's all nice and good, but we kind of don't really want to be doing that. We should reinvent ourselves a little bit. And so we started focusing on this idea of being more of an innovation lab. So what does being an innovation lab mean compared to being just maybe a software consultant? Well, first off, you bring to the table to your customer something called design thinking. Now, design thinking is very appropriate if you want to be doing innovation for your customers, who want to improve their processes and all of that. Again, I'm not going to spend like too much time on this, but it is important that you understand the basics, I think. So design thinking is split in 5 different effective areas. First off, you empathize with your customer. You try to sort of understand what their problems are. And the way to think about it is that part of the process is one of the parts of the process where you throw a wide net, meaning that you really look at everything, at what are the real pain points, and sort of try to get like a big general idea of what the customer is doing. You're not limiting yourself to, oh, we're only going to attack this or that problem. You're just like really trying to see how it feels to be your customer, right? And then, sorry, I'm going to come back here. Then you define a little bit more what you want to attack as a problem with your customer. So you sort of redo another focus pass, followed by another pass where you go wild. You have a lot of ideas about that specific problem you're going to solve. And once you've had all the ideas, you've thrown all the fun stuff out into the wild, and you've done this session with people to sort of determine what are things we could be looking at. Then again, you sort of do another focus pass, and you try to prototype and effectively test the prototype and modify the prototype and refine until you have something that qualifies as both an innovation, but more importantly, innovation that has an impact for the customer, which is like the whole point of the exercise, right? So if I solve and reduce all this back down a little bit more, the process looks as follows. You basically put yourself in the user's shoes, right? Pretty intuitive. You imagine what you could be doing, you imagine what the fixes are, and you make it real. And at the end of the day, you redo this a few times, and you reiterate, and you improve on the solutions you've been looking at until you have something really cool. Now, I'm more of a technical person. Like in the company, I'm the technical founder, not like the administrative incorporation business guy. That's not at all my gig. And so I tend to focus a lot more on prototyping, and it's also why I'm here today talking to you about technical stuff, right? And so the 2 customers I just presented to you had something in common with them, and that is that they worked a lot with live streaming video. And one of the big insights I came out of these projects with is twofold, basically. For Bell, we were using the WebRTC stack to live stream video, and we found out how fast it was, how reactive it was, and also how great it was as just like a network stack, effectively, because you had a lot of people in the call. They could communicate, obviously, with video and audio, but with WebRTC, you also get very low latency data pipes that you can use. So if you think about WebSockets and things like that, WebRTC is actually a lot more responsive as a technology if you want to do WebSocket-like projects and be live connected to things. So we had this insight that, hey, with the Shopify, the Instacart stuff, if we were able to basically connect to a powerful server somewhere that could look at these images, maybe being limited by these tablets wouldn't be such a big deal, right? We just connect to a more powerful device in the store and start doing much more sophisticated type of image analysis. And so, we started looking at what was out there on the market, and we ended up after I'm sad that I didn't find out about this project while I was at Bell. It was actually very much the early days for them. After Bell, I found out about Livekit right here. And so Livekit is my new favorite API, quite frankly. It's what we're looking at today, and it's what's been instrumental in helping our innovation lab sort of build this live streaming stack and helping us sort of try to combine that with all the new AI capabilities that are out there. So what's fun with Livekit is you get client libraries for all the platforms that you can see here. You get all the server code as well. while they do have a for-profit mission and they do offer hosting services that you can imagine that are world-class, what's really interesting about this project is that it is proper open source, and it's not going to try to really lock you into any vendor. What I'm going to demo today a little bit is all a local server. It's all locally set up stuff. I'm not actually using any of their cloud infrastructure, only their open source components. And these are components you could very reasonably host yourself if you don't need, say, to have people jump in on a call from remote parts of the planet, right? You could still do that on your own if you wanted to, except, networking setup for that kind of stuff is a bit more time consuming. So, they have a nice offering there is what I'm trying to say, I guess. All right, so Livekit is cool. No vendor lock-in, I've talked about this. So one of the things that's kind of nice to show to people and to make them understand what sort of lit me up a little bit about their tech stack is effectively they've been showing this demo. I saw this demo last year, and that's where they were demoing themselves, plugging into like various text-to-speech, speech-to-text stacks and the ChatGPT backend. And lo and behold, I think something like 5 or 6 months after they announced officially that they were the partner for OpenAI, and they have like an actual real-time OpenAI API that they've added to their stack. They also support all other platforms, obviously. But so what's kind of interesting here is that with Livekit, it's trivially easy to connect a chatbot, a live speaking chatbot, as you would have with the dynamic apps that you're getting from OpenAI themselves on the phones, to your call. So you could add agents that are programmed and prompted in very specific ways to help people that are on the call to do whatever you can imagine, right? The sky's the limit there. So thing is, today is not going to be a demo of how to build your own voice chatbot on Livekit with OpenAI. First, because if you want to do that, just like follow this URL. Really easy. I recommend doing it. Lots of fun. Quite a nice toy to play around with. But and here I'm sort of reposting a little bit of a rant that I think people should go look at. Now, I'm quite a fan of chatbots and how they help you work and how they help you think about stuff and how they're effectively a really powerful search agent for all the knowledge out there. But I believe in also that this is a correct little rant saying that they're not necessarily the future. And the reason behind this sort of thinking is as follows. If you think about chatbots, as far as like UX affordance, who's familiar with the term affordances with UX in general here? One person. Okay, that's good. So I can talk a tiny bit about it without being redundant. So the idea of an affordance is effectively what kind of levers and buttons and sort of affordances, things that the UX proposes to you to interface with the system. So if you think about like a calculator, right, you have all the number buttons and the operations. That's pretty specific. I'm trying to count, right? So I am being guided towards a path that makes my work the most efficient. If you think about a chatbot, you're effectively given the dictionary as an interface, right? Like every word is valid. Of course, we know how to build sentences. It's not that bad. But if you start thinking about, I'm trying to do a workflow as fast as possible, right? Chatbots are effectively probably a pretty bad solution. They're really good at exploring things and certain problems, but if you think about it, affordances are important, and so chatbots are not necessarily the future, even though generative AI is quite interesting and has like definitely quite a bright future ahead of it. Anyway, so I'm going to go now into a bit more of like the technical bits of how Livekit works and how WebRTC works. So if you're not a fan of like a corporate sponsored tech stack, these things still apply to WebRTC, so it's also a little bit more of generic knowledge. But here it's more like Livekit's lingo that still applies. So concepts you should be aware of, the concept of a room, right? The conference room, we all get the idea. People are in a room right now and they are participating in the session. Anybody here could voice up and we would all hear the audio, right? Participants, people in the room, and tracks. Tracks are effectively video and audio. You can have different tracks. You have a separate track for each participant, but you can also have data tracks. In the case of Livekit, they sort of make it a bit easier than real WebRTC, where they offer one nice data track that everything can go onto. But if you think about WebRTC, it's a little bit more complicated. Anyway, doesn't matter. Let's move on. All right, so Here, I'm not going to actually go into live coding right away. I'm going to demo a little bit of the toys I brought with me a bit later. But I'll just give you the general idea how you set up a Livekit server on your own machine. If you're on Mac, you just do a brew install Livekit. You start the Livekit server. Of course, you have to sort of make a little effort to make it into a development environment. You have to configure a small config file, but I'm going to skip over that here. And by default, in most of the cases, it's going to do all this stuff for you. You can see sort of the answers here, like it's going to generate an API key called dev key for you, and all this nice little stuff. But once you've ran this command, you have an actual WebRTC server running on your machine. And yeah, it's ready to handle calls, have participants jump in. But how does the rest of that mechanic work, right? Because you start to think about, okay, if probably nobody here is old enough to remember IRC and the good old days of the internet, but you need to secure rooms, otherwise you're going to have bad actors jumping in and starting to troll everybody and sort of act like bad people, etc. So you need some sort of authentication service to allow people to jump in on a call. So you need some sort of auth service, and in this case, the Livekit server is part of the stack that allows you to mint authentication token that can be handed back to your customers, your clients, I should say. And when the clients get these auth tokens, then they are allowed to directly connect to the Livekit server and say, okay, I've been sort of recognized by some other authority. I have access to this room for X amount of minutes or hours now, and I've been allowed to post video or not, and to participate in the call in very specific ways. So that's how the Livekit server sort of lets people in, etc. So the thing is, at that point, you sort of need to start thinking about, well, what is the app that is going to mint these tokens and sort of give them to my user? So you need an extra app. So in our example, we have another app called the Livestream app, which is not the Livekit server. And so you can see the URL here. I'm listing the URLs a bit later. It's a Livestream server that Livekit provides. I've tweaked a version today that I'll be demoing in a second. Once you've installed it on your machine, it's an npm project. You just need to run npm run dev. It will boot up, and you'll have a server running that's ready to be opened on your browser. So at this point, I'm going to put up a slide for a second that you might want to take pictures of. It has all the resources and documentation. It's going to come back later if you're scrambling for your phone. Don't worry about it. And I think I'm going to try to jump into a quick live demo instead of maybe going too deep into the different Android subsystems and all of that. I'm going to try to make these slides available on whatever way we usually do. I'm not sure. Anyway, we'll figure it out. I will likely have them up on the GitHub. Sorry, gathering my thoughts here. All right, so let me just do a quick live demo of what I've just talked about, sort of make things a little bit more exciting. And I just need to make sure that I'm mirroring the screen correctly so everybody will have a chance. And that's kind of tiny, so I'm just going to fix that as well. All right, it's kind of, all right, let's see. My God, we're in at this point, I think that's readable for people in the audience. I will assume so, because otherwise we'll be at 640 by 480, and that'll be ridiculous. All right. All right, so let me just demo a little bit here how the actual stuff will work. So what I've just talked about in the slides is starting a Livekit server. I'm not going to show you my configuration file, because this one, quite frankly, has a few details that I don't want to share. In this case anyway, yeah, I'm running the default setup. Anyway, let me just start that again. All right. The small thing I'm doing different here is I'm binding to 000 on my own local personal little network. So that's just to make sure that my Livekit server is available to the different devices I've hooked up to this. And next up, I'm going to start the server that allows me to mint these tokens and participate in a call. And so it's kind of nice on Mac. You can sort of control-click to jump into a call like so. And so you can see here, this is the live streaming app that's running on my device. And I'll talk about this in a second, but the Livestream device does two things. It can connect itself to a room. It can also mint tokens for other participants. So at this point, what I'm going to start doing is I'm going to jump right away into the little car demo. So I brought my little live streaming cars with me today. And if all goes well, they're still connected. I need to check on my phones. OK. So, all right, there we go. So I have two devices here today with me. I have a small car that's controlled by a phone. This is the phone that's controlling the car. And so I'm going to start my Livekit app here. And so what I'm going to be doing here, I'm running an Android application that is configured to connect to the live streaming server running on my Mac. So when I start a live stream, what happens is that the device should, hopefully, if all goes well, sometimes when I start it's a bit picky, connect to my Macintosh here, and I can start a live stream. So let's see. So the first step is to double check that this works, and if it doesn't, then it's not that complicated to restart the process, which is what I'll do right here. Right, live demos for the win, it's always a thing. I have to admit that I haven't been like the best Android developer on this stuff. Like there's a few state management items that need to be corrected. And hopefully we're going to be good in this time around. The other thing to double check is if I'm getting signals on the server. So it looks like, yeah, I'm seeing the remote device trying to start everything. This is looking good. There we go. All right, so we're having video. So that's nice and all. I'm flipping the camera around to look at audience participants, and then just to make anybody too shy, I'm going to sort of turn it towards a camera, like more generic stuff. There we go. All right, cool. So next that we need to check is that, do we actually have access to this thing? So from my web browser, I'm going to join an existing stream. Like I've given the name of drone to these rooms, pre-programmed to just like make things a bit simpler. And here I'm going to call myself web client. So with any bit of luck, yeah, we're in good shape. All right, so muting the audio because that's a thing. All right, I'm happy. Quite frankly, I've run these demos in the past very badly, and every time they effectively failed because writing your own WebRTC stack is hell. So this is all Livekit in effect. Very little skill on my part needed here, I can tell you that much. But all right, cool. So we have our little session, so that's nice. We can see stuff. Now, what else can we do? So this is not really part of the machine learning part. It's more of the part Etienne likes to show off his projects a little bit. So we're going to not spend too much time on this. It works, it works. If it doesn't work, we'll say screw it. But I have like another client here that can connect to this call, which is this remote. And so here what we're effectively trying to test is more like, is the data channel capabilities of WebRTC working for us? So if I join the live stream with this thing, now I know you can't see, but all right, that's good. I can actually, I have to mute this thing before we get feedback. Oh yeah. So my test devices, little story while I'm doing this, all my test devices are effectively broken little Android phones. So my screen is actually not responsive when I'm trying to mute it. Now it is muted and things are good. Life is fun. All right. So we have this little car here. Yeah, there we go. So I'm tempted to just like give the remote to somebody in the audience, but I think like it's going to be very distracting. We could do this. Who wants to? How about you? You want to drive the car around a little bit? Oh, he says no. All right. Oh, there we go. You're the first hand I saw raised, so try not to tip this camera over. So have a bit of fun with that. So, and then we can see the live stream here, right? Yeah, okay, that's cool. So we can also see it like from this angle, which is kind of interesting. All right, so this is all nice and good. While this is happening, like I promised some machine learning, so I'm going to go straight into the demo part where I can hopefully run some of that machine learning stuff and demo it properly. Of course, I sort of totally forgot to leave my IDE open, so it's going to be a sec. Okay, we're not so bad. It's pretty quick. All right, let's see. Da, 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 da. Huh. Which one is the project? I do believe it is this one. All right, cool. Oh, it disconnected. Oh no. Oh, press on, there's a little, wait. Oh, you have it here, it's fine. Yeah, we'll just, oh yeah, you got the right reflex right there. So hopefully we'll be able to join it back. And try to play with the joysticks again. Yeah, all right, we're good. All right, the bugs. Sometimes if it disconnects while it's like running, it'll just keep going straight, right? Doesn't have smarts yet, we're working on that. So, let's see. Not to waste anybody's time, which one was it? I think it was shape. So what we can do here is, like, I have these agents right here in Python configured to connect to the same call. I'll double check that they're connecting to the right call, because otherwise it's going to be a bit, damn it. I have all my keys. I can't show you my keys. Okay, I'm going to hope it's going to jump into the right call, and then we'll see. The problem of live coding, right? If you want to, you have a config file where everything is, and you have private keys in there, you kind of don't want to open them to the great wide world to look at, sadly. So, yeah. No, it's fine. I'm gonna. Well, yeah, you're right though. But actually, I'm thinking I'm on the wrong track. Anyway, let me go back to my slides, and I can always run more of this demo a bit later because I feel like I'm gonna. The talk ends at we have 40 minutes, I think. Oh, we have a full hour. Oh, you shouldn't have said that to me. So, let me see. I'm gonna do one last try here. Ah, that's the one, right? Oh my gosh, okay. That explains a few things. All right, so we have a full hour, so bear with me for a second, and I promise I will respect your time and not go over the top here. I just wanted to open this project. There we go, that's it. All right, I don't know, I lost my Python config at some point and things went weird. Cool. Oh wait, that's the wrong project, that's why I remember now. All right, live coding. It's very boring, I know. Very, very boring. But there we go. The thing is, I like to sort things and rename my folders obsessively, and I don't always check that my configurations have been put up to date since then. All right, now we have it. So I have a few demos here that I'm going to run, and these are properly configured to connect. So I believe that the one I like is shape is going to be the one we're going to run right now. So I just want to, I protest. I'm going to write a complaint. All right, I do have some last try, last try, and then I give up. I'll show you the slides instead. Sorry. Bad prep on the host's part. It's all my fault. I apologize. All right, let's get back to the on-Rails stuff. Cool. Let me just stop my sharing like this. We're going to go back to use a separate displays. Jump back to Keynote. All right, let's see. So I have a few slides here about the Android code necessary to run these live streams and how to split everything up. I'm going to skip over all of that because it's, first off, open source, and second, it's kind of boring to look at code, quite frankly, right? I will stick to the more important bits of understanding the technical aspects of the high-level stuff so that if you want to run these kind of demos at home, you can do it as well. And so let me jump to this diagram right here, which is effectively one of the main points I want people to remember. When you're working with this stack, if you're going to check out the Livekit servers, you're going to have the Livekit servers running. You're going to want the Livestream app as well running on your machine, which is the one responsible for minting the auth tokens I've talked about, and which is what you should imitate if you want to run your own stack. So for me, for example, if I'm trying to build a project for a customer that allows people in a certain amount of time, I need to do my own auth, verify who they are, verify that A is allowed to speak to B and that they actually want to be in the same room together, etc. And so that's all going to happen in a Livestream-like app. You can use Livestream as your basis to start everything. It's very well made. It's a full-on Node app, and quite respectably well built. And I suggest people look at that if they want to move on forward with that. And once you have your other client apps talking to this server, getting their tokens minted, and then allowed to participate on the call. All right. Let me just skip a little bit ahead. So this is all like explaining, well, I had my cat while I was doing my demos, so at some point I was sad she left, but then I just painted her back in. So again, the slides with the codes, we'll get back to that later. This slide is here to effectively explain that if you wanted to do your own WebRTC, there's a lot of stuff you need to look at. And the good news is the Livekit is doing it all for you in a way that's most likely going to be the most efficient that you can sort of get to. And I'm going to, instead of explaining every line, I'm just going to go, hey, it's confusing, right? But I will explain some of the terms so that once you start working with WebRTC, you're able to a little bit better understand what's going on. So you have ICE. That's a term that's going to come back a lot. So it stands for Interactive Connectivity Establishment, right? A really nice mnemonic. I know I remember this every single time I think about ICE. Of course, it's Interactive Connectivity Establishment it stands for, right? But what it really means is that two devices sort of need to know what their public IPs are as regards to one another. So when you're running ICE, it's the way that WebRTC sort of tries to find each other's addressing, even though you're talking to each other behind a firewall. STUN is for Session Traversal Unities for NAT. So it's, yeah, another mouthful, basically. Once you sort of try to talk directly to one another and it doesn't work, which happens once in a while, fairly often. I don't have numbers, but if you want to be able to establish connections in a reliable way, you need to be able to basically go through a firewall without issues. And so sometimes you can't talk directly to one another. That's just a fact of life. So turn servers are there to act as a third man, a third party to help you do that. So what does that look like a bit more concretely? Well, when you have two peers trying to talk to one another and communicate to one another, they first are going to have to talk to a stun server. And effectively, a stun server is saying, what IP do you see me at? And so you're talking to the internet and you're asking it, hey, what's my IP, man? Because I'm behind a firewall. I don't know what's my IP for the outside world. You are told what that IP is. You have to communicate it with your other peer, and then that allows you to sort of make a list of potential connections, paths that you can try. If those don't work, because you're behind a firewall that doesn't allow for it effectively, that's when the turn server is going to come in, and that's what's going to allow you to connect to one another, even if with a little bit more lag, but not that much typically, if the network configuration you have doesn't allow for it. So that's actually what's going on behind the scenes. I'm not going to explain this. I'm going to suggest that you look at it another time. What I'm going to point out is that the actual URL on the Mozilla docs is this thing, right? So that sort of says it all. OK, so the takeaway is Livekit does a really good job at doing fairly complicated stuff. It's not rocket science, but it is complicated to get right if you want things to connect reliably. All right, so that's the live streaming app. So I'm going to talk a little bit now about the more juicy tidbits, which are what can you do when you connect machine learning to a live streaming channel like that. So most of my examples are using Python. This is kind of surprising to me if you know me. I think Python is king for a lot of stuff now. I've had so much fun prototyping little machine learning projects with Python and sort of realizing how close it is of a cousin to Kotlin if you decide to use it that way. What I mean is that Kotlin is known as a functional, very strongly typed language. And what I appreciate about Python is that if you decide to work that way, it's very easy to do so for me as a Kotlin developer that's a bit more rigid in my way of approaching things, because I like that type safety that protects me against myself kind of thing, right? So The other thing, oh yeah, that I should mention is that for these demos, I've talked about how the clients mint their own tokens. So what's interesting about the Livekit APIs for Python is that they allow you to connect to a call, but they also allow you to talk directly to Livekit and mint your own tokens. And the reason for this is that if you write your own Python code, the presumption is it's going to run in a server. And so you can give it the keys to mint your own tokens, so you can skip all this sort of nonsense I was showing earlier about talking to a centralizing server. You are part of the stack, so you're going to have the keys so you can mint your own tokens, and you can basically jump into any call you want. Of course, as a developer, it's your responsibility to make sure that your ML agents are jumping in when they're needed and wanted. And so the first code example I'm going to show is so that's presumably our participant up there, our cat. That's my cat, Guimauve. I quite love this animal. But at the bottom, what we were seeing is like a rotating sort of sequence of colors. So this little piece of code right here, that's all you effectively need to connect to a WebRTC call and start outputting pixels and getting those into a video session. So the Python bot here, I'm skipping over the setup where you get the auth keys and all that, of course. But this is setting up a loop that just writes pixel colors to a buffer and cycles them over time and sort of writes that back. So the key elements here are that at the top, you write your own RGB frame, you create it, you write in it, and you use this output source, the RTC video source, to effectively dump the image that you generated into the call. And that's called again in a loop for every, for every frame that needs to go out on the call. So next, though, it's nice if you can output, but you do need a way to be able to input frames if you want to start doing some interesting stuff, right? So in this case, I'm running like a face detection model, one off the shelf from Google. People are probably familiar with it. It's one in the media pipe stack, if my memory is correct. And so here you could set the top, the key points here that you have an input stream and an output stream here. And as you'd expect, the input stream gives you this guy making silly faces. And you can use each of these frames to put them into the model. So you feed them to the model so it can do an inference, detect where the face is. And I've sort of skipped over the code that that writes up the mesh on top of my face here. But that's code that actually is provided by Google anyway. So that's all stuff you're going to find into the repo. But this is sort of an example of how easy it is really to sort of decide to grab specific streams of information, start providing them to a model that's running some type of inference, taking that data, writing it back over a frame, and feeding it back into the call. It's nothing magical here. It's like fairly straightforward. So more sort of ideas now of what you can do this and what we're working on, for example, to sort of help sort of showcase what we can do to customers and also solve some of our own little problems. So, I've basically just talked about this in the past, but I'm revisiting it in the context of this machine learning project. So I have a problem at home. I collect vinyls. I have way too many. I'm also partner in a company that does apartment clearances for folks. So if you know Got Junk, we have something similar to that I'm partner in. And so as you could expect, people sometimes just like leave vinyls there when they ask for somebody to clear out their apartments, and there's a succession and stuff like that. So what started out as a healthy little habit of having a few hundred records turned into this monster thing where sometimes people come up to me with pallets of records, and I'm like, okay, this is no longer collecting. I have to do something about this, and we have to try to sell them, is effectively the problem we have. And so I've been looking at it through the eye of like a software developer and thinking, okay, what can I do here to sort of fix this problem? And the first part is I need some way to do an inventory. So I've talked about this in the past. There's other talks out there that you can find if you look at my YouTube or you look me up online. But what we've done lately is that we asked the kids this summer to start actually filming, flipping through the records and filming what they see so that we could start building some sort of inventory. What's interesting about these methods is that even, you don't have to necessarily be on a live call, right, to process video. It's the same code. Anyway, so what we want to do is first inventory it and eventually maybe sort of start selling it. But if you have thousands of records on hand, which would be true for comic books or collecting cards or any type of collectible, you're going to have a lot of crap for the gold, right? So this is actually a sample of one of our boxes that we went through. And you know, there's like some things that you'd expect are pretty cool. My wife ranked them. I thought she was kind of harsh to say that something that's worth $10 online is poop. But I guess her cutoff was $12 or something here. But you know, we did find a nice find at the top right there, like the Ween record worth like $160. So that was kind of like, oh, okay, cool. But what we're thinking is, right, we have thousands of these things, so we need a way to quickly sort through that. And so visually what it would look like is effectively you go through the box, you can run just a background removal model would yield this. And once you have that, if you've played around with like existing off-the-shelf vision models with LLMs, you can ask an LLM, what is this record? Can you give me a product description? And put this in JSON, please, so that I can look it up later on Discogs and find out what the price is. And you can do this in an interesting way once you have video, is that you know in time where each record appears. You can identify the box with a QR code, and what that allows you to do and what we've been doing at home, it allows you to sort of take a clip. When you see the QR code, you say, okay, this is the start of box 1512. And for the rest of the recording, until I see another QR code, I can identify each of the records and see in time where I got them and make that available as search with another LLM at the end of the flow. So what we've effectively built is a way of a search engine through our collection that we don't even have to sort it, and we can find out in which box and which shelf something is, and find out if it has value, so that by rifling through our records, we can create a really quick inventory. So that's the kind of thing that you can do you know, as a batch job, which was quite frankly where we've been at so far. But we think there's like a lot of power in bringing that to a live streaming world, where somebody going through, you know, searching through somebody's collection could find out pretty quickly what's worth what, right? So those are the kind of ideas. A few slides here showing how you can run product descriptions for this. This is some of the prototyping stuff we've had. Other ideas we've been playing around with in a small demo. This is sort of a more of a nicer, like we've been playing around with different QA type assistants, quality assurance assistants, and thinking that if we have an assistant filming a session, we can start, you know, extracting metadata and logic. The better way that we thought of explaining it to folks is to think about Legos. When you have Legos, nowadays they're pretty sophisticated. You have like a lot of instructions that you need to follow and a lot of little bits that you need to sort of prep, right? And so a nice prototype that we've started putting together is as follows. What we try to do is scan for the notices for the Legos, try to see how many pieces of each type we need, and sort of run a session where we can, you know, live sort of detect the amounts that we need and start making a count. This is not our latest demo, but you sort of get the idea of what's possible here. And what's kind of fun is that, and that's another point I want to bring just quickly while I'm seeing this, is that here we're using OpenCV to sort of distinct the shapes of what the things we're looking at. But when you combine OpenCV with Florence 2, which allows you to see shapes and do searches through videos, and another model called SAM2, which we've experimented with, you end up with like fairly powerful ways of sort of identifying what's been going on in your video, tracking objects without sort of deduping them, and even being able to do stuff like have a live frame and do a prompt query search. And so, yeah, that's the kind of stuff that you can get up to once you've started setting up a live streaming system. So I think I'm at like at time pretty much. 40 minutes is a long time. So thank you for your time and your patience. I'm here for questions and anything else like that.